The heading for Lesson 3.2 for your notes is solving equations by using addition and subtraction. What you'll learn, surprisingly enough, is how to solve equations using addition and how to solve equations by using subtraction. They pose the question, how can equations be used to compare data? The graph shows some of the fastest growing occupations from 1992 to 2005, when this book was published. The difference between the percent growth for the medical assistants, which isn't in the graph, and the percent growth for the travel agents, which are, someone said, must be 5% in these years. An equation can be used to find the percent growth expected for medical assistants. If M is the percent growth for medical assistants, then M minus 66 equals 5. You can use a property of equality to find the value of M. The property we'd want to use to solve that equation would be the addition property of equality. If an equation is true and the same number is added to each side, the resulting equation is also true. So in symbols for any numbers a, b, and c, if a equals b, then a plus c equals b plus c. So they showed adding 3 to both sides. 7 equals 7, yup. 10 equals 10. Or adding negative 6, 14 equals 14. If we add negative 6 to both sides, 8 still equals 8. Oh, I can't stand it. Let's solve the equation they brought up. So m minus 66 equals 5. We would want to add 66 to both sides of the equation. And so we get m equals 71. If the same number is added to each side of an equation, the result is an equivalent equation. Equivalent equations have the same solution. One of the main things they're going to ask us to do in algebra is to solve an equation. To solve an equation means to find all the values of the variable that make the equation a true statement. One way to do this is to isolate the variable having a coefficient of 1 on one side of the equation. You can sometimes do this by using the addition property of equality. For our first example, they asked us to solve h minus 12 equals negative 27. Then check your solution. Always a good idea. So to undo subtracting 12, I'm going to add 12 to both sides of my equation. So h equals negative 27 plus 12. The signs are opposite, so I'm going to subtract and keep the sign of the bigger number. So h equals negative 13. Am I done? Almost. It says then check your solution. So when I go into check, I'm going to substitute the negative 13 back in where h was in the very original equation. So negative 13 minus 12, does it equal negative 27? Oh, no, it does not. That would equal negative 25. Something's wrong. Go back. Check your work. I added 12 to both sides. That's right. Oh, but wait. Negative 27 plus 12 should have been negative 15. Let's try the check again. See if that's better. Negative 15 minus 12. Does it equal negative 27? You bet. Okay, so take that 15 seconds and do the check because sometimes it will save you from the wrong answer. Now, doing this live, I'm always curious to see who will follow me off the cliff, but I'll just have to ask tomorrow who believes me that, and believe me the first time that negative 27 plus 12 was negative 13. Okay. Solve k plus 63 equals 92, then check your solution. So we've learned our lesson. Checking is a good idea. We're going to subtract 63 from both sides. We have k equals 33, I hope. Let's check. 33 plus 63 is 96. Uh-oh, that's not what I wanted. Houston, we have a problem. Check our arithmetic. Okay, so 12 minus 3 is in fact 9. 8 minus 6 is in fact 2. Okay, try the check step again. See if it works better this time. 29 plus 63. Oh, sure enough, it does equal 92. That's what I wanted. Okay, I'm not joking, guys. Take your time and do the check step. You should never miss a solve an equation problem when you have an easy check step to do. Okay, we had an addition property of equality, so why can't we have a subtraction? If an equation is true and the same number is subtracted from each side, the resulting equation is true. For any numbers a, b, and c, if a equals b, then a minus c equals b minus c. So they started with 17, and if you subtract 9 from both sides, sure enough, still equals 8 equals 8. If we start with 3 and we subtract 8 from both sides, 3 minus 8 is negative 5. Yup. Okay, example 3, we've got c plus 102 equals 36. Solve, check your solution. So I want to subtract 102 from both sides of the equation. And I get c equals negative 66. Is it right? Let's find out. Substituting back into my original equation, where there was a c, I'm putting negative 66 plus 102. I really hope this time it works. And sure enough, negative 66 plus 102 is 36. The signs are opposite, so we subtract. Yay! Check step worked. Okay, they challenged us to solve this equation with fractions in it 2 different ways. Well, the first way I would do it would be to undo add 4/5. I would subtract 4/5 from both sides of the equation. Oh, but rats. To add or subtract fractions, we need a common denominator. Our common denominator is going to have to be 15, because 3 and 5 are both prime. There's no common factor we need to worry about. So I need to take 2/3 times 5 over 5, and 4/5 times 3 over 3, and I'm going to get 10/15 and 12/15. Okay, so 10/15 minus 12/15 is going to be negative 2/15, which I don't have to worry about reducing. The other way we could have handled this, instead of subtracting 4/5, we could have used the addition property of equality and added negative 4/5. My 4 is looking like a y. But we know that adding a negative is the same as subtracting, so our work would come out exactly the same. We'd have to have a common denominator of 15, so we'd have 10/15 plus negative 12/15. So either way, we're getting negative 2/15. I've done the problem 2 different ways, but I did not do the check step, and I think you're convinced, I hope, that it's important. So check, negative 2/15 plus 4/5. I need a common denominator, it's 15. So I have negative 2/15 plus 12/15 is 10/15, which reduces to, divide by 5, I get 2/3, which is what I wanted. Hooray us! Write an equation for the problem, then solve the equation and check your solution. 14 more than a number is equal to 27. Find this number. If we translate the verbal expression into an algebraic equation, more than gives us a plus. So 14 more than a number, they used n, is equal to, equals 27. Okay, all we need to do is solve. I'm going to write it a little bit closer together. 14 plus n equals 27. So to undo, well, the 14 is before the n, but that's okay. I can still subtract 14 from both sides because we know that 14 minus 14 is no teen, aka 0. So we have n equals 13, and we're going to check to make sure it works. 14 plus 13 is, in fact, 27. Oh, happy day. So 13 is our answer. For our last example, the Washington Monument in Washington, D.C. was built in 2 phases. From 1884 to 1854, the monument was built to a height of 152 feet. From 1854 until 1878, no work was done. Then, from 1878 to 1888, the additional construction resulted in its final height of 555 feet. How much of the monument was added during the second phase of construction? Okay, making a plan, if we put it into words, the first height plus the additional height equals 555 feet. They decided to let A equal the additional height. I can live with that, A for additional. So the first height plus the additional height equals 555. So to solve, all we need to do is subtract 152 from both sides of the equation, and we get A equals 403 feet. We'd better check. So going back to the original equation, if we add 152 plus 403, we get 555, which is what we wanted. Hooray! Our big ideas for the lesson were using the addition property of equality, so we can add the same thing to both sides of an equation, and the subtraction property of equality. We can subtract the same thing from the both sides of an equation to solve, which means get a variable on one side of the equation by itself.